They say that good code is like a love letter to the next developer who is going to maintain it, right? And sometimes you come to an existing code base and you're thinking to yourself, this developer was definitely not a man of love, you know. And then you're also thinking to yourself, like, have you ever gotten to a company, you're going through their code base, and then you're thinking, like, man, what is going on here? What was this guy drinking? Or maybe you're picking up your existing code base 3 months, 6 months down the line, and you're thinking, like, what the heck? Yeah, the question is, what is the problem, right? The problem is simple, not just for the new developer or also for the company, because as a new developer, you want to enter the company, hit your ground running, you know, make your move, let them feel your impact to go through legacy codes or go through some crappy code base, and then 3 months down the line, you're still struggling to understand what the previous developer was trying to do. And also, no company, trust me, no matter how liberal they claim to be, wants to keep paying you 3 months, 6 months for just trying to understand the code base. I'm saying this from experience. So, the question is, how do we fix it? Most times, developers, how do developers do their quick fix? Most developers just, create a new directory, create a new folder, write your stuff down there and move ahead. And they have this mentality, if it's working, don't touch it, right? But the problem with that is that it gets messier, right? It gets messier, and then not just for you, but for the other developers coming after you, because you're going to leave that stage, and the developer is going to come in trying to understand what you were trying to do. But even if it's for you, 3 months down the line, you can't remember everything you wrote, you have to go back there, and it just gets messier. So sometimes other developers, what they do is, create a new version without any new improvements. The version is clean code, right? In basic terms, clean code is just a way of writing code that are maintainable, scalable, easy to read code, and also testable. That's just the basic definition of clean code, right? On a real basis, right, clean code doesn't just start with writing code. It's not just about writing code. You have to start from the very top, which is, you have to start from the architecture. And the very basics here, there are 3 layers to clean code architecture, right? We have the controller layer, controller or handler layer. We have the service layer, and we also have the repository layer. So how are these layers interconnected? How do they work, right? So basically, the controller layer handles the routing, right? We have our CMD, the handlers. You get your request, your payload from the client, and you do whatever you want to do with it. And then you send it to your service layer, where the service layer handles the business logic, whatever logic you want to do, addition, subtraction, whatever logic you have, that should be done in the service layer. And service layer also depends on the database layer, right? The repository layer, which does your database stuff like the queries. So basically, the controller layer depends on the service layer, while the service layer depends on the database layer, right? And that is how they interact. They try to, it's kind of like a long code to try and be having everything long together. For example, you can see this example. What is wrong about this code is that you have this is supposed to be like a handler function or a controller function, but you're having your database query here, and you're also trying to implement your logic service here, right? This is bad for business because you can't test this code, because when you're going to test it, you're supposed to be able to test codes layers by layers. You're supposed to be able to test your database layer, service layer, and also controller layer separately. Also do test them all together. But you can't really test this like that, right? So yeah, like I said, why was that bad? Tight public, I mean everything mixed together. You have your database, HTTP handler, everything mixed together. Difficulty to test, like I've explained. Hard to maintain. So if you want to make any change, you have to go back and refactor that code. And most things about refactoring a working code is that it breaks things, right? And then there are no abstractions. You can't really scale that code up, right? Without abstraction. So this is like a good example, very basic, very simple example of repository layer. You can see this just handles the repository, connects the database, does all the database query here. For this example, we are going to try and stick to use users. Yeah, you're just getting users. That's just the repository layer. So this is the service layer. Like I said initially, service layer depends on the repository layer, right? So you can see you have the user service there. All it does, it depends on the repository layer. So whenever you get maybe an ID from the handler or controller that calls it based on the business logic that they're trying to implement there, you can just do whatever logic you want to do. Maybe you want to get the user from the repository layer. You already know that the basic user service is already having access to the repository layer, and that's that. And then we have the next slide, please. And then we have the handler layer. And then for the handler layer, like I said, the ID is coming from maybe the client, whatever the consumer, the customer, and you're trying to, whatever you're trying to do. So now, the handler layer depends on the service layer, right? And based on the, like I said, the business logic you're trying to implement, you're trying to query, then you can just go to that service layer and then have access to that business logic. So, next slide, please. So now the question is that how do these, since they are separate layers, right? So what interacts between these layers? What moves around these layers? What interacts between these layers? So that's why you might hear things like entities, main entities, right? These are not separate layers. It's not a separate layer on its own, but these are this represents the core business objects that encapsulate both data behavior, right? They move through the layer. They move through the layers. For example, this next slide. All right, for example, we have, let's say you were building an e-commerce platform, right? What would be your domain entities, right? You might have something like user, product, order, payment, etc. For example, for the user entity, we have the user structs here. You can have this. And then you have your product structs here. So you can actually know that you can get the user, let's say you're trying to create a user, right? You're going to get it through the user structs, right? You send it to the service layer, and then you save it to the repository layer. And then the same thing, you're trying to get it, right? With the ID, you are sending back. But that's why I said domain entities, they move around the different layers. They're not really a layer, but they move around different layers. So these are some of the key concepts of clean code base, right? Solid principle, we'll be coming to that in a minute. Try. You try as much as possible not to repeat yourself, right? You try to keep it, you abstract a lot of things, not to repeat yourself. And then there is keys. Keep it simple, stupid, right? You have to try and keep it simple, especially when it comes to naming convention. Let someone take a look at your name and be able to say, tell what you were trying to implement, and also your code should be a little bit easier. Then handle error properly. That's one of the good thing about Go. It enables you to handle error the best way you can. And now, from my experience, one of the issues that a lot of startups have is Yagni. You ain't gonna need it, right? You're trying to come up with a startup. You want to do everything at once because you feel like you need to have this big, powerful application that you put out there. But the problem with that is that most times you ain't gonna need that stuff. So you're just wasting valuable time that's supposed to do what you're supposed to need, go to market, best market, and then come back and implement, right? You might be doing writing a code base, trying to implement, you should be able to scale up, right? And then we have encapsulation, which just means keep things that are supposed to be private, things that are supposed to be public. Although a lot of times, all of us just want to make it easy, keep everything public, and then have access to it. But you should be able to know what you want to have access to, right? Next slide, please. All right. So to the solid principle, right? Solid principle is actually a very, very important concept when it comes to any programming language. In fact, I don't know if you go to, if you have done a lot of interviews, enough interviews, you should know solid principle, because that's one of the key principles that you ask for. right? So we start with the S, single responsibility principle, right? It says each class or module should have only one reason to change, meaning it should have only one responsibility. So in simple terms, you're having a function for addition, should be addition. You're having a function for subtraction, should be subtraction, right? So in our example here, you can see we have a register user, and the register user is doing save to database and send email, right? Those are two different things that anything can go wrong. Something can go wrong in the send email, something can also go wrong in the save to database, right? So how do you track this, right? How do you correct this? Okay, let's say you want to add another email services. How do you do it? Right? So if you look at the other side, you can see that these are separated. They are actually separated into what do you call it? They are separated into their own basic service, right? Separated into different services in which the user service depends on each of them. So you can easily call the user repository or the email service any way you want it in your code base, right? It's as easy as that. So now, for O, we have the open-close principle, right? This says entities should be open for extension or closed for modifications. This means you should be able to add new functionalities without modifying existing code base, right? Sometimes you want to, sometimes you're working with, let's say, PostgreSQL, you want to scale it up to, MongoDB. You should be able to do that without having to go back to modify your code base, right? For this example, you can see, still on the register user. Let's say you register user, you want to notify the user that you want to register, right? You want to notify the user. The thing is that we have different ways of notifying users, right? We have notifications, we have SMS, we have WhatsApp, we can name it, right? Just imagine you're writing this code this way, and then you're just writing notify user, right? And then you implement email user. And then tomorrow you want to come back and implement SMS, SMS notification. That means you have to come back and modify this code base, right? Which is what this principle is against. But if you abstract it out into an interface, you can see the notifier interface which has the notify function signature, right? So whichever notification thing that you want to use, be it SMS, email, WhatsApp, whatever, what they have to do is implement that same signature function, which is notify. For example, here you can see I have the email notifier there and also have the SMS notifier there. So wherever you want to use it, whichever one you want to use it, in whichever function, all you have to do is initialize the one you want to use and use it without having to break your code. You can also add new ones like WhatsApp, whatever. You have to go and modify new code base, right? So, and then the next principle would be list-call substitution principle, right? This says that an object of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. Yeah, and there's a lot of English, but bear with me. It says, in simple terms, if class B is a subclass of A, then you should be able to use B wherever A is without altering the program behavior, right? In a quick example, I am a human, I am a man, I am a woman. I should be able to use I am a human, man and woman, they are both humans, right? So I should be able to use man, woman, human in the same sentence correctly without altering whatever it is, right? So in our example, you can see that let's assume you want to create our user repository into admin user or ordinary user because we want to give different roles to admin and different roles to ordinary user. So we are supposed to be able to do that so you can interchange those users that you are using without affecting your program, right? For example, you can see this. We are breaking down into admin and regular user here, right? Giving admin some whatever, maybe admin can save and can whatever you want to do there. And so if you look at the main function from main, you can see that whenever we have the user repo, we also have the admin repo, right? We can use that in that service. In that service, new user service. But because the new user service is taking user repository. So you can pass in any of the user, their main user or the ordinary user into that new user service without breaking your code, and you can use it any way you want to use it. That's a simple thing. That's just a simple form, right? So the next for the ID principle, interface segregation principle, right? It says no client should be forced to depend on methods it doesn't need, right? So basically, instead of having these long, big monolithic interfaces, break them down. For example, you won't need to have your email service and your repository service in one interface. It doesn't make sense, right? Break it down, take it out. And sometimes they might even be able to break down some repository, like now you're trying to break down the user into reader and writer, because you might figure out that an admin should be able to read and should also be able to write. But an ordinary user, you don't want to give an ordinary user the opportunity to write, right? So you can also just break it out, and then you can see there are regular users just depends on a user reader, while the admin user can read and can write, right? That's it. Then to break down your interfaces to smaller ones so you can easily use them any way you need to use them. So the D for the solid principle stands for the dependency inversion principle. High-level models should not depend on low-level models. Those should depend on abstraction. Again, abstraction, very important in Go. So if you look at this one, this user service is depending on database, which is, let's just assume it's the PostgreSQL, right? Now, when you come out tomorrow and say, no, we want to scale it to, we want to scale up to MongoDB, what do? You come here and try to correct things, which is against the rule of open close principle, right? Or you might end up breaking a lot of things. So what do? Instead of having it this way, why not have like what do you call it, an interface in which that has user repository has this thing, maybe a signature function signature of save, and maybe you're using Postgres, you can make that function signature save. Same thing with MongoDB, you can make the same function signature save, and use it whenever you want to use it interchangeably, right? It's as easy as that. Instead of having to depend on a particular database, you're depending on the interfaces. Yeah. So the question is why clean code, right? Why clean code? So by trying to clean code, right, your code should become more readable, right? You merely looking at the function name, you know what the code says at a go. Maintainable. Someone can just pick up your code, developer should be able to pick up your code and start to do something with it, right? Scalable, like I've explained with the Mongo, with the databases, and then collaboration and easy to review. I should be able to pick up your code and not have much issues going around your code base and test it. I must be able to test your code so as to ensure that things don't break before going into production. But with all this about clean code, there's actually a myth about clean code, right? The myth is that clean code is like clean garbage. It doesn't exist. I know it's funny, but it doesn't really exist because, in fact, they say the cleanest code is an empty repository, it's an empty code base. When you don't write anything in it, that's actually the cleanest code base you can have. So, but now let's take a look at some things here. If you look at this is supposed to be clean code base, right? This is like from what I've explained, supposed to be clean code. You are separating create user or create user by ID to their different interfaces, right? And then you are trying to make user service depend on it. This is too much work, right? Compared to what you have there, you just have one interface representing you just have one representing everything, right? Here you're separating everything to different interfaces. You just have one user repository, one user interface that implements everything, right? So you can see this is in the sense of clean code, this is cleaner compared to that. But who can tell me what is wrong with this code? Anybody? It's simple. It's not even technical. Nothing technical. It's just a simple thing. And over engineering, complex. There's a lot of things where when we get into a place, sometimes we senior developers, right? We tend to over-engineer things sometimes, right? Not because we are comfortable with it, but we don't know if the next developer coming after will be comfortable with it. So the thing about clean code is that clean code most times is about trade-offs. It's about trade-offs. For example, you have to trade between complex and simple code base, like I showed previously, right? If it doesn't serve your purpose, why? If it doesn't serve any specific purpose, why do it, right? Easy to understand versus optimize performance. Sometimes clean code might be easy to understand, but sometimes when you are going into your code base or you're trying to implement something, would you go for easy to understand? You would have gone for optimized performance. I'll give an example of that. Then test coverage versus development speed. Sometimes just have clients waiting for things and then like someone said, how do you check errors? You say, well, when clients tell me there's error, right? Clients can't lie. So basically, they will also have another one, try do not repeat yourself versus wet. Write everything twice. So now, example of how performance can be impacted with clean code, right? If you look at the two examples I have there, you can see some range, right? Very simple. Looking at it, you know what it does. Takes to start at integer. And then you just looking at the function, you know that it's ranging through and returning the sum, right? Very simple. You don't have to crack your head. Anybody understands that. But then look at the second function, like the optimized one. Sum range optimize, right? It just returns the formula. You don't know the formula, right? You don't know the formula. You're looking at like how do we get to this formula? That's not clean code, right? But now if you run this code, right, you can see the so-called clean code is taking 55 milliseconds to execute, while the optimized not so clean code is taking 42 nanoseconds. Which would you prefer when it comes to impacting performance? That's for you to answer in this. So now, the thing about we talked about dry versus wet, which brings us to abstraction proper, right? It is said that wrong abstraction is much more expensive than duplication. You don't just start writing code and then all of a sudden you are trying to remove everything, abstract everything, write everything once, and then you are trying to do. So most from experience, what you should do, right? Write your code, right? When you write your code, you may not go through your code and say that, oh, these things have been written more than 2 times. It should be written more than 2 times, then you start abstracting. That's why we have do not repeat yourself versus write everything twice. Right? For example, where you can go wrong with that is that just imagine you're trying to implement a payment process, right? And then we all know that payment processes, right? You can have fiat, credit card, crypto, right? But you would be mistaken to think that all of these should have the same abstraction, right? Because they should have the same, because they have different logic. They might need different payload, right? So you can see here you're having one process payment and you're trying to process different payments methods. That would be costly on the long run. Why not just break it down into process credit card payments and process crypto payments, right? I mean, you don't have to abstract everything, right? In summary, what are we trying to say? Clean code, dirty code, whatever we're trying to say. What we're trying to say is that clean code is subjective. Really, clean code is subjective. The way what I might consider clean code in my partner might not be what people consider clean code and vice versa, right? Because it depends on a couple of things, right? For example, as a developer, put in mind that you're an author, right? So, as an author, what you do, you're trying to show your thoughts in a way that is easier for other people to understand, right? So, as a developer, that's what you should put in mind when you're writing clear and understandable code, knowing that whoever picks up this code should be able to know your mindset, think about what was it trying to do, has it done it, does it work? Yeah. Then, there are fundamentals in everything you do. In every speed has fundamentals, just such as architecture, right? You have to, like I said, three basic layers: the controller layer, service layer, reposition layer, how we communicate with each other. Function naming, it has to be clear. Maybe test, you have to write, they are fundamentals, you just have to research on them, know the fundamentals. And three, very, very important, because we do this a lot at Partner. When you write a code, try to justify it. You try to justify your code base, because sometimes people will be asked, okay, why did you use this? Why not this? Why are you extracting this? Why not repeat it? You know, you should be able to say, I did this because of this. I did this because it's the performance, like I showed you about the performance one. I did it because it impacts performance positively. You should be able to justify your code, right? You don't just put things out there and send it to production. And another very important point, reading is hard. Yeah, that is, whether you like it or not, reading is hard. In fact, one of the hardest things to do in software development, to me, is code review. I mean, I shouldn't be scratching my head to think of what you were thinking about, or you were drinking while writing the code, and I'm looking at the code and saying, what was this guy thinking about? I mean, it's hard. So please, when you're trying to write your code knowing that reading is hard. I might not have that time to sit down and read your code line by line, right? Just like Anthony said, we are lazy. In fact, that is the core of being a developer, laziness. Because we are looking for the easiest way to get things done. I'm not going to come and sit down and read the whole logs. No, I'm not going to do that. So, if you keep in mind that we are lazy, you're going to always look for the easiest way to get things done. That includes writing code properly that people can understand. So, here are a few of my references. You can get them here. I can share the slide whenever you need it. Or if you have any questions, you can always reach out to me on my socials, YouTube, LinkedIn, X, and Instagram. Thank you for listening.